Hey guys, welcome back to Stat and Research 2. Hopefully you guys had a great catch-up week, whether you're catching up on this class, another class, or just your mental and physical well-being, because that is important. Um, we're approaching or entering kind of the second part of this semester for this course. With that, I want to kind of walk through the schedule and the remaining part of this course, just so you guys are familiar with what we're going to start with this week and then kind of where we're going to end. So here is the schedule for the remaining time you are in this class. We're going to be talking about random effects and mixed effects this week. We'll go into nested and split plot designs, and then we're going to go into a lot of multiple linear regression. There was a request from a couple students asking if I could post a review on simple linear regression, so I'm going to be working on those videos as well. After we talk about regression, I'm going to talk about the analysis of covariance, which is a mixture of ANOVA and regression, so that you guys are at least introduced to that topic. With that, we'll have 5 homeworks left. This isn't a mistake. Homework 11, these 2 weeks will combine homework 11. And then our final exam, I'll be posting it May 3rd, and it will be due by May 10th. So you'll have about a week to complete your final exam once it's posted. I will do another review session probably this week on Thursday. It's kind of far out to really put down a date just yet, but probably Thursday night of this week, we'll do a review session to make sure you're prepared for your final. I'll also be holding office hours during this kind of final exam week. With that, just giving you the lay of the land, where we're starting this week, which is going to be random effects and mixed effects models, and kind of where we're heading. With that, I'll also be posting some practice problems, help you guys get some extra credit points, but also practice and see if you guys kind of generate any more questions, see if you guys have questions to ensure you are hopefully understanding the material the best you can. Don't think I have any other class announcements other than midterm corrections. If you're doing them, keep working on them. If you have questions, ask. But other than that, let's get started on today's lesson, which we're going to start with lesson 9, random effects. So this week, again, we'll be covering random effect models and mixed effect models. Hopefully, as you can tell by the name, the mixed effect models is going to be a combination of random effects and fixed effects. So in order to get to lesson 10, we're going to break up lesson 9 into 3 parts. The first part, i.e. this lesson, is going to really focus on understanding the difference between a random effect and a fixed effect. As a foreshadow, all of our notes thus far have really been focused on fixed effects. We'll put a definition on that in a second. The second video is going to focus on how you do the analysis and how the analysis is different. The third video is going to be the example and how to apply this to an example. So let's get started. Thus far in this course, we've only focused on fixed effects. And what a fixed effects is when we have a predetermined fixed levels. So our factors are set ahead of time, and our inferences is only limited to these effects. So let's look at some examples we've had. In lesson 2, we had an example where we were comparing the reflectivity measurements of 4 paints used on a highway. In this example, we were only interested in these 4 paints and how they differed from each other. So we had predetermined fixed levels, which were the 4 paints, and our inference only focused on these 4 paints. In lesson 7, we had an example with the bologna where we had 3 treatment factors. We had the flour blend, we had the flour type, and we had the SPI. And for each of these factors, we had specific levels that we were interested in. Okay. Another example that I thought of was, let's say we're interested in comparing the effect of 3 types of drugs. Only those 3 types of drugs on controlling tumors. Then we would only pick those 3 drugs and look at the inference. Okay. So fixed effects is when we have specific predetermined levels that we want to make inferences about and compare. Okay. Random effects are the levels of factors that are randomly selected from a set of available levels. And this inference is going to, when we use random effects, inference is going to be generalized to all the available levels of the factor or the population factor level. Okay, let's look at some examples to maybe help make this a little bit concrete. So example 1, let's say we wanted to assess whether the working hours are different by major. Okay, so we're at tech and we want to see if statisticians work more or less than engineers, work more or less than all the other various types of majors. We have biomechanical engineers, chemistry, all that. However, the hard part is there's a lot of majors and it would be hard to randomly sample exactly all of those. So here, to help us, we are only going to randomly select 3 majors out of all the majors of tech and do our analysis. Okay. Another example could be a textile company weaves fabric on 10,000 looms. So this company has 10,000 looms where they do their fabric. Okay. The company is interested in comparing whether the looms are different in the company, and it's impractical to go to all 10,000 looms and sample and compare if the looms are different. So a better way is, out of those 10,000, we're going to randomly select 4 and we're going to do our analysis on those 4. Okay. So in this case, with random effects, we don't care about this, how the specific levels are compared. We're more interested on the population level. How does the population compare? Again, to help demonstrate this, let's go to a picture. So here's an experimental plans for both fixed effects and random effects. Okay. In a fixed effect analysis, we have, in this case, let's say we have 3 fixed interested treatments. These are the 3 treatments we want to look at. Okay. So then we take these 3 treatments and we're going to assign and randomly apply them to our experimental unit. Okay. In a random effects kind of design, what we have is we have all these options. This is our entire population which we can choose from. We randomly select 3 treatments, and then we take these 3 treatments and we randomly apply them to our experimental unit. Okay. Notice this extra step of randomly assigning the treatments to the experimental unit is just good design of experiment protocol. Okay, so maybe to demonstrate this a little bit further on how these 2 can differ, if we were to repeat this experiment, the fixed effects experiment, we will always get these 3 treatment effects. They're fixed, that's what we're interested in. Then we would randomly apply them to our experimental unit. For our random effects, let's say we repeat this, and our repeated experiment we might sample maybe A, H, J. So out of this, we're going to randomly sample 3 of the levels, which if we did it again, might be A, H, J. Now we have our experimental units, however many, and we're going to randomly apply these treatments we selected to our EUs. Okay. To hopefully give us a more concrete example, let's look at a food supply example that will carry throughout the rest of this lesson. So an agency wants to evaluate the accuracy of measuring calcium in food supplements. There are a number of possible labs and a number of chemical assays for calcium. We are going to choose 3 labs and 3 assays randomly, okay? Then each lab will use all 3 assays so that each assay lab combination is randomly assigned to 2 of the 18 prepped samples. So what this looks like, let me get an extra piece of paper, is here we have assays. In our entire population, maybe we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, ... Okay, this would represent our entire population or however many we have. Assays. What we're going to do is we're going to randomly sample from this population 3 assays. Let's say 2, 5, and 8. These are now our treatments for assays. Okay. Same thing for labs. So we have labs. And just so we don't get these confused, we'll call these lab A, B, C, D, E, F, G, H, ... I don't know how many labs we have, okay? Now, we go in, we're going to randomly sample 3 labs. So let's just say maybe it's A, F, D. Now, these are the labs we're going to look at. Okay. What I just demonstrated shows us how we got this statement right here. The 3 labs and assays are randomly selected from their population. Okay, so that's what I demonstrated here. We have a population of assays. We're going to sample 3 randomly. We have a population of labs, and we're going to sample those 3 randomly. Okay, that's where the random effect kind of part's coming in. This statement right here, each assay lab combination is randomly assigned to 2 of the 18 prepped samples. What this is saying is that now we have different combinations. So we have assay 2, lab A, and we're going to apply that assay lab combo to 2 samples. We also have assay 2 with lab D, and we're going to apply this treatment combination to 2 samples. Okay. So we come here, we see we have assay 1, lab 1, and we have 2 samples. Same thing, 2 samples, 2 samples. And this is how we got this data. So here we have 3 random assays, we have 3 random labs, and for each assay lab or treatment combination, you could call it, we have 2 replications. With that, you should hopefully have at least a better understanding of the difference between fixed effects and random effects. In our next lesson, we're going to focus on looking kind of at the ANOVA table and how inference between fixed effect and random effects differ.